With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so question is saying this: identify the compound A in the following reaction sequence, right? So we have to identify this A compound, right? So when this A compound is treated with this CH3MgBr S positive and constant H2SO4, right? So it is forming a B compound, right? So when B undergoes ozonolysis, right? So it is forming up this compound. It is forming up this, you can say, product, right? So let's say this is forming a P product, right? So let's say this is forming a P product, right? So now we have to find out this A compound, right? And we have given the information that this A is giving a positive iodoform test, right? So this A is giving positive iodoform test, right? So positive iodoform test, right? So what do you mean by this positive iodoform test, right? So the compound which give positive iodoform test, so must have CH3CO group, right? So this group must be there, right? So for showing a positive iodoform test, right? Or you can say it, or CH3CHOH, right? So or CH3CHOH, right? So CH3CHOH, right? So if there is a if in the compound there is this group, right? So CH3CH or CH3CO, right? So those compound will show a positive iodoform test, right? So that means in our compound A, this group must be there, right? So this group must be there, right? So and this is there, right? So this can be checked by our option, right? So you can see here in the all option we have CH3CO, 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 CH3CO. That means A compound have a CH3CO group, right? So that means it contains a carbonyl group, and we have carried out the reaction with Grignard reagent, right? And Grignard reagent react with carbonyl in a very efficient manner, right? So now, but we have to find out the what should be our A product, right? So what should be our A product, right? So to do this question, we have to solve this question retrosynthetically, right? So we have to go for retro method, right? So the retro method is that we have to make a reactant from the product, right? So we have to make a reactant from the product, right? So now you can see that B is, when B undergoes ozonolysis, it will form a product P, right? So I'm drawing this product P, right? So let's say this is our product P, right? So this is our product P. So let's say this is our product P, and it is like this, right? So let's say this is our carbonyl and this is our H, right? And there are two methyl group, right? So I'm drawing like this. There are two methyl group, right? And this is a carbonyl, right? So this is a carbonyl, right? And this is methyl group, right? Again here, right? So this is our product P. So you can write like this: CH3 over here, right? So CH3 over here and CH3 over here, right? So this is our product P, right? So you know that when this product is forming, right? So when B undergoes ozonolysis, right? So B undergo ozonolysis, right? So that means we know that in the case of ozonolysis, when we carry out the ozonolysis across the double bond, so the product will be formed look like this, right? So you can see here, this is a, you can say, let's say this is a alkene system, right? So this is alkene system, and when we carry out the ozonolysis, so just you have to put two oxygen over here, right? So and the product will form look like this, right? So you can see here in one product, you can see here this is one product and another product is this. So another product will be look like this, right? So you have to just put this product, right? So this is the method for carry out the ozonolysis, right? So now if we same here, if you just remove this oxygen and combine this bond, right? So by combine these two carbon by double bond, so you will make this compound again, right? So that means this product can be formed, right? So this product is formed when this compound will form look like this, right? So you can see here, this is our benzene ring and this is our carbon, right? So this is our carbon and these are two methyl groups, and again this is a methyl group over here, right? So this is a methyl group over here, right? So now you can see here, this is this carbon, right? So this carbon is connected by double bond, right? So this carbon is connected by double bond, right? So when, and there is a hydrogen over here, right? So this must be our B compound, right? So this must be our B compound, right? So because when we carry out the ozonolysis, right? So when we carry out the ozonolysis, right? So when we carry out the ozonolysis, so this compound will form this compound. That means B compound will form this product, right? So this product, right? So that means B must be this, right? So B must be this, right? And B is forming from this series of reaction A, right? So that means this B is forming from A, right? And A has a, you can say this CH3CO group, right? So we have to find out the A on the series of this reaction, right? So when we carry out the reaction of Grignard reagent and you can say carbonyl group, right? So the reaction will be look like this, right? So you can see here, when we carry out the reaction of Grignard reagent and carbonyl, right? So carbonyl, right? So you can see here, this R negative will attack on this carbon, right? So the bond will go like this, and there is a formation of this product, right? So O negative over here, and this is H and this is R, right? And when we carry out, let's say when we carry out the hydrolysis, right? So that means H positive over here, right? So in the presence of water, so this OH, right? So this O negative will abstract this proton, and there is a formation of secondary alcohol, or you can say primary alcohol, right? So there is a formation of alcohol basically, right? So this is R, right? So in this reaction, that means when we carry out this first two reactions, so there is a formation of alcohol, and when we carry out this third reaction, that means concentrated H2SO4, there is a formation of alkene, right? So there is a formation of alkene via the carbocation intermediate, right? So via the carbocation intermediate, right? So that means H2SO4, and heating condition will give there is a formation of carbocation intermediate, right? So that means this product will form, right? So now you can see here the A compound must be this, right? So this A compound must be in which of this following, right? So that means A may be this compound, this compound, this compound, this compound, right? But we have to check it, right? So let's check it one, right? So let's check it for one, right? So let's do it, right? So if I check for one, right? So the compound A, right? So compound A look like this, right? So this is compound A, right? So when we choose a compound A look like this, right? So this is our compound A, this is CH3 over here, there is a carbonyl, and this is CH3, right? This is CH3, right? So when we carry out these reactions, all the reactions, so we have to obtain this product, right? So we have to obtain this product that we have derived, that means we have to obtain this product, right? So this product we have to obtain, right? If this is not getting, we are not getting this product, that means this is not our answer, right? So that means this is not our compound A, right? So let's check it and carry out the reaction, right? So first in the first reaction, right? So in the first reaction, you can say, let me erase here. So in the first reaction, we have carried out the reaction with Grignard reagent, that is CH3MgBr, right? So that is CH3MgBr, right? So this CH3MgBr negative will attack over here, and the bond shift go like this, right? So this bond go like this. So there is a formation of this compound, right? So there is a benzene ring over here, there is a benzene ring, right? And this is benzene ring, and this double bond system, this is methyl group, and this is O negative over here, and this CH3 look like this, so attach will like this, right? So and this is stabilized by, you can see here, MgX, or you can write MgBr, right? So or you can write like this, right? So over here there is Mg and this is Br, right? So this is Br, right? So after this we have add a water in it, right? So after this we have a water in it, right? So that means water H positive, right? So this will abstract this negative will abstract this proton, right? And there is a formation of alcohol, right? So there is a formation of alcohol, right? So the formation of alcohol will be look like this. So this is methyl group, and this is OH over here, and this 2-methyl, right? So after this we have add concentrated H2SO4, right? So this is our first reaction, right? So you can see here this is our first reaction, and after this is second, right? And after this we have add concentrated H2SO4, right? This is concentrated H2SO4, and then heat, right? So heating condition, right? So let me heat it, right? So you can see here, so if I heat it, right? So if I heat it, so the product will be look like this, right? So the concentrated H2SO4, right? So concentrated H2SO4, this is concentrated H2SO4, right? And then heating condition, right? So we know that this, from this H2SO4, this H positive ions will come out, right? So this H positive ion will come out, right? And this H positive ions, right? And the lone pair of this oxygen will abstract this proton, and there is a formation of this group. There is a formation of this group. You can see here. You can see this is the group like this, right? So here there is a 2-methyl group, and this is OH2, right? So this is OH2 positive, right? So now we have given the heat over it, so this group will leave, right? This group will leave, and there is a formation of this group, right? So there is a formation of tertiary carbocation, and this carbocation is very stable because it is allylic carbocation, right? So this is allylic carbocation. So that means you can see here this is our product, right? So this is our product. So this must be our product, right? So you can see here this is benzene, right? And this is our electrophilic system, right? So this is electrophilic system, and this is nucleophilic system. So this will attack over here, and there is a formation of this product, right? So you can see here there is a formation of this product. So I am writing like this. So this is the methyl group over here, and this is the product, right? So this 2-methyl group here, and this bond look like this, right? So now this becomes positive charge, right? So and this is also stable, right? So to benzene lose its aromaticity, so to gain its aromaticity, right? So to gain its aromaticity, hydrogen proton will come out and the product will be look like this, right? So the product will be look like this. So you can see here, this is the product, right? So there are 5 membered ring and these are the methyl, right? This is the product we have obtained, right? So this is the product we have obtained after this. If I'm choosing A, right? So that you can see here, but in the case of B, right? So we have derived B like this, right? So we have B derived like this. So if I draw the B, so B would be look like this, right? So B is looking like this, right? So this is our B, the given data, right? So this is our benzene ring and this is our, right? So this is our benzene ring, right? So let me draw it here, and this is benzene ring, right? So this is our B, right? So you can see here there is no methyl group, so or there is no methyl group on this double bond, right? So this is our actual B, right? So this is our actual B, right? And this is we are getting from this reactant A, or you can say compound A. That means A cannot be our compound, right? So because we are not getting this compound B, right? So that means we are not getting this compound, right? So that means this cannot be our A compound. So this cannot be our answer, right? So this cannot be our answer. So let me eliminate it, right? Now if we check it, right? So if we check it, the same reaction will look like this, right? So take place, look, right? So now you can see here there's a 2 methyl group over here, right? So there's 2 methyl group, right? So one methyl group is looking like this, right? So you can see here this one methyl group, right? So I'm just writing here this 2 methyl group, right? This 2 methyl group, right? So that means in the product, right? So in the product, these 2 methyl group attached here, right? So in the product, these 2 methyl group attached here, but in the actual B, right? So there is no methyl, right? So that means this cannot be our answer, right? So this cannot be our answer, right? Now you can see here, across the double bond there is no methyl substitution, right? So that means and the reaction is taking place at this center, right? At this center, right? So that means this part is unaffected, and in the product we are getting this part, right? So we are getting this part is unaffected, right? So now you can see here, and the product will be from here, from this product, right? So this must be our answer, right? So this must be our answer, right? And you can see here in the case of D, this is methyl group, right? This is methyl group. That means in the product B, we are getting the product like this, right? So we are getting the product look like this. So from here, if I draw it, the product B, so the product will be look like this. You can see here, this would be the benzene ring, right? And this is double bond, and this is methyl group, and here this methyl group, right? So this would be the product, right? So but the actual B is looking like this, right? So this cannot be our answer, right? So this is not actual B, right? So this cannot be our answer, right? So in this way I can eliminate also B, right? That means we are left with the correct option, that is option C, right? That is the option C, and we can say that this is option C, that the compound in the option C is our A compound, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.